So in this problem, we have a graph, and we will need to match it to the correct function. So we have to take a close look at our graph. So here's the graph they gave us, and I've maximized it so we can see it better. And what I want to know is, how does that compare to the exponential function 4 to the x? If it's exactly the same, of course that's the one we'll pick. If it's different, then I can make the adjustments to this equation and know which of the ones that they listed is the one we should choose, which one matches this picture that they give us, this graph. So I'm going to start by making my chart and graphing 4 to the x. So if I pick -1, 0, and 1, I need to plug those in to my function to see where they go on the graph. So 4 to the -1, remember in our negative exponent rules, that is the same as 1 over 4. 4 to the 0 power, any non-zero number raised to the 0 power is equal to 1. And 4 to the first power is just 4. So now we've got 3 points, and we know the general shape of our exponential function, so we should be able to graph this one. So if I go over here and I go to -1 and a fourth, and that's about here, and I've got 0, 1, and I'll plot that point here, and then I have 1, 4, and I'll plot that point up here. And I'll sketch out my exponential function. One of the first things I notice is that it is flipped around this y-axis here. It's backwards. Ours goes in this direction, theirs goes in this direction. So it's backwards. That means a reflection. So we are going to have to look and see if we need to negate the entire function, or if we just need to put a negative with the x, because that you have to check to see, is it a reflection about the y-axis or is it a reflection about the x-axis. Reflections about the y-axis mean that we are going to make our x negative. So it's going to be at least a 4 to the -x. If it were only reflected about the x-axis, in other words, if it were 4 to the -x, then it should just swap my points. And so that it would look like this. But as you can see, that's not the only thing going on with our graph. So it's not 4 to the -x. There's something else. There's also a shift involved. So we have to think about a horizontal shift. How do we get a horizontal shift? And we also need to remember that horizontal shifts come before reflections. We have horizontal shifts, stretches or shrinking, reflections, and then vertical shifts. That's the order if you've got more than one transformation going on with your functions. So we need to shift it horizontally and then reflect it to see where it goes. So if we take our blue 4 to the x graph here and we shift it, and I'm going to try to draw that in green. So if we take the 4 to the x and we shift it back one, we'll shift it to the left one. Move it back here so that this point gets moved over, this point at the top gets moved back one, and this one gets moved one. So I've shifted it back one. So now it looks like the mirror image of the one that they gave us. So what is the green one? I've shifted it horizontally to the left. Horizontal shifts happen when you add or subtract from just the x. So the green one should be, and those are always backwards. The horizontal shifts are always backwards from what I think. Since I shifted it to the left, I would think that I subtracted 1 from my x, but in reality we do just the opposite. So it would be an x plus 1. That's the green one. Now, if we take that and we reflect it, that means we've got to take the x and we've got to negate it. So we're almost there. We've almost figured out what in the world we've done to this one. So if I take the function that I have written in green, the 4 to the x plus 2, and I just change the x to a negative for this, the one that they gave us, that makes it a 4 to the negative x plus 1. Or if we look at the ones that they gave us, another way to write the negative x plus 1 is to rewrite it as 1 minus x. Negative x plus 1 and 1 minus x are exactly the same thing. So this is the function that we're looking for.